Okay, we've got this region R here that's bounded by the line y equals 2, this red line. The line y equals 1 minus x, and the graph of y equals e to the x, this blue curve right here. And we want to revolve that around the line x equals -1 using the washer method. Okay, and when you use the washer method, your typical washer is perpendicular to the axis of revolution. So for each y between this 1 and this 2, we can picture this as a typical washer. There's another one right there. Okay, and those distances are horizontal. So we have to solve each of these equations for x in terms of y in order to get representations for horizontal distances. So if y equals 1 minus x, then x equals 1 minus y. And if g of x equals e to the x, then x equals ln of y. Okay, and so here's a sample disk for every y. The x-coordinate along this line is always -1. For every y between 1 and 2, this x-coordinate is on the line x equals 1 minus y. So for every y, this is 1 minus y. And similarly, for every y, the x-coordinate of this point is ln of y. And we want to use the disk method, which is pi times, in our case, the integral from 1 to 2. We're integrating along the y-axis of the outer radius squared minus the inner radius squared. So we need expressions for the outer radius, which we're going to square, minus the inner radius, which we're going to square. And that'll be dy. Okay, so how can we get expressions for the outer radius and inner radius and square them? Well, the outer radius is the distance from this point on the axis of revolution to this point. And that's the x-coordinate at the right minus the x-coordinate at the left. Okay, so this is the outer radius right here, ln of y minus a -1. That's the outer radius, and we're going to square that. And then the inner radius is the distance from -1 to this x-coordinate, y-coordinate at the right minus the y-coordinate at the left, the x-coordinate at the right minus the x-coordinate at the left. So that's 1 minus y minus a -1. This is actually 2 minus y, the quantity squared. Okay, so if you want to simplify that a little bit, this is what you get. Here's an example of finding that same volume of revolution using the shell method. Okay, and using the shell method, your typical shells are parallel to the axis of revolution. I won't go into detail on how we got all these, but this is the average radius, and this is the height of the shell multiplied by 2 pi. We need two different definite integrals because the formula for the height of the shell changes between x is -1 to 0 and from 0 to whatever this x-coordinate is. It happens to be ln of 2. Okay, there you go. Hope that helped. Hope that gave you some idea. If you have any questions, post a comment.